See if like dark skin is any
Hi,
different.
everybody.
So I'm trying.
The Kent Washington Education Luncheon. Everybody here in attendance, I hope you all had lunch and enjoy yourself. I will now present our CEO, our Kent, is going to talk to you about the Christmas party?
Holiday party.
Holiday party.
Yes.
Non-denominational, I apologize.
Hi, everybody. So glad you come and for everyone who's on Facebook Live. Just want to let you know we are having a holiday party this year. We weren't able to have one last year, so we're really excited to have one this year. It's going to be December 9th at Ironworks. And I'm here today to let you know that we are going to be having a 50-50 raffle and selling tickets. We're doing pre-sale tickets. They're $10 a piece. We're promoting, not promoting, but this will benefit A Wish Come True. And we do have a wish child. Her name is Isabella. And please, if you're interested in buying a ticket, come see me. All right? And anyone who's watching today, give the office a call at 885-9300. Thank you.
Anyone? So as stated previously, this is the Kent Washington Association Education Committee. This is a education panel that we have on a monthly basis in which we provide education to our membership. This month we have a fantastic presentation by Grover Fugate, who will present on the coastal erosion and sea level rising. When I do present, Grover, when I have a chance, have a chance to talk to him. He's amazing. He has a wealth of dollars and different information on which I've never watched this. I see from here for the last half hour from today. I will introduce Grover. Grover, thank you very much.
Okay. Morning, everybody.
Morning.
I'm just going to move this out of the way so it doesn't block your view.
I'm with you on that.
So, primary discussion is going to involve sea level rise, but we're also going to discuss erosion and coastal storms because they all interplay with each other. I hope you don't mind this. This is actually the Watch Hill Yacht Club down in Westerly. This is a sunny day flooding event. The culprit for this is actually a storm drain right in here. It's supposed to take water off the lot and convey it to the ocean, but now it's the other way. And this is becoming much more prevalent and will become a lot more prevalent as we go forward. And I'll discuss why in a second. So, going back to your high school science, this is what's causing a lot of the issues, this whole greenhouse effect and what generally gets called global warming. And it is if you go back to your science, what you're going to see is that the sun is emitting long-wave radiation that's coming in, it's re-reflecting back. But what's happening is the greenhouse gas is re-reflecting that back into the atmosphere and trapping the sun's long-wave radiation, which is giving us the heat. The ocean absorbs about 90% of that heat, and it did a very good job for a number of years. But the problem is it's retaining that heat now and starting to cause some other changes. And we'll talk about that here. So if we look at going back almost 500,000 years, this is a graph that shows a couple of things here. First of all, it's going to show the CO2. Then it's going to show the average temperature, and you're going to see then sea level rise. One of the things you have to understand, there's a lag in the system. So what happens is we emit CO2 and it gets in the atmosphere and it traps heat. The heat then, it takes a little while to start to warm the atmosphere. And once the atmosphere warms, it takes a little while to warm the water. So there's this delay effect that's built into the system. The problem with that for us is that what we've already put into the system, we haven't seen the results from. And it's baked in at this point, and there's a certain amount of sea level rise that's already baked in. Even if we went to zero emissions today, we're going to see sea level rise over the next several centuries. So as you can see, we're sort of off the charts in terms of where we're at for carbon dioxide in this upper graph up here. And typically what you see is it tracks, and you'll see there's a little bit of a lag here, and here, and here, meaning that it doesn't perfectly line up because of that lag effect. But you can see the atmospheric temperature rose, and then sea level rose. Going back into history, back in geologic time, about 13,000 years ago, we had these large continental glaciers that covered most of North America. Here in Rhode Island, there would have been a mile of ice sitting on top of us. And sea level was about 300 to 400 feet lower than it is today. It's going to start to obviously climb up now as we start to see this. And this, again, is another sort of different depiction of this. It's showing that we have the observed temperature over here, the warming that's occurring, and then the simulated. What this is basically showing is that there are a lot of people that argue, well, it's just a natural cycle that occurs all the time. And yes, there have been warming and cooling trends that have occurred, usually over tens of thousands of years, not within 100. And when you go to simulate what's causing the warming trend, because we actually should be in a cooling trend right now, the only thing that really mirrors what we're seeing is the CO2 generated by fuels and other sources. There's also other greenhouse gases that are going to start to contribute, such as methane. And we'll talk a little bit about that here in a second. But this is what is driving this. So sea level rise. Sea level rise comes from a number of sources. And the primary one that we tend to talk about is what's called eustatic sea level rise. And all that means is that as you warm water, it expands. So as we start to warm water in the oceans, it will start to expand. The only place it has to go is over land. There are other factors that kick into what are called relative sea level rise. And all that means is relative sea level rise is what's causing the sea level rise at your particular spot. There are actually places in the earth that are seeing sea level rise, or sea levels drop. And that's due to things like plate tectonics and those types of things. Or in Alaska, where they're having a lot of melting glaciers, you're getting what's called a rebound, meaning that the crust is lifting up again now that it no longer has the weight of the glacier on it. So there are areas that we are actually seeing a rise in landmass relative to sea level. So there are a number of things that can cause sea level. One of the things that's important for us is currents, ocean currents, because if we start to slow the Gulf Stream, which we're starting to do now, or starting to see, that can result in our area, been predicted about another 2 feet of sea level rise on top of the global estimate for 2100. So you really have to look at what's going on in your particular area. Here in Rhode Island, we've generated some very good maps, so if you're not worried about any other place other than Rhode Island, you should be good with what we've shown you here. But if you start to get outside of Rhode Island, then it becomes much more important to understand some of these other factors. Mid-Atlantic, for instance, around Annapolis or Norfolk, their landmass is actually sinking as well as sea level coming up. So they're getting a double whammy, and they're really starting to have some issues down there associated with that. Sea level rise, again, this is going back 18,000 years here, but as I said, we have these large continental glacier systems that were on top of the United States and Canada and Russia and all the rest of it. And then what happened is sea level rise started to rise about, say, 14,000, 15,000 years. And what you're seeing here is what's called a meltwater pulse. Now, the point of this is that sea level rise is not likely to be this nice little curve that's going to go up. You could see some of these meltwater pulses where you could get as much as 1 foot to 2 foot within a decade if we have, for instance, the collapse of an ice sheet in the Antarctic. So the other thing this sort of illustrates is as sea level rise started to decline, we started to see delta formation. So this is, if you think of India and deltas, the major river systems, this is where most of the inhabitants are on these delta systems. Those actually started to form about 9,000 to 8,000 years ago. Our barrier systems, so if you think of the Outer Banks and those places, those are barrier systems, either barrier spits or barrier islands. And those started to form about 5,000 years because sea level rise started to slow to a point where those systems could actually stabilize and form. So when we think about the US, our systems have been stable for about 5,000 years. From sea level rise, I should say. And for the last couple of thousand, it's almost been zero, yes.
How do scientists know what happened 18,000 years ago, or even 8,000 years ago?
There are,
Is it estimates? Are these just estimates?
no, there are markers that they, so for instance, if you're looking at like CO2 concentrations, what they do is they take pores in the ice sheets themselves and other places. And inside those pores, there are little gas bubbles that are trapped that they can measure what the CO2, so it gives you an indication of what the atmospheric content was at that time. So that's how they do that. There are markers that they can see where the previous shorelines were going back in time, so they can actually see submerged shorelines, for instance. There are other indicators such as marine organisms that maybe have left within the sediment or fossilized. So there are a number of ways that they can track that and deal with it. They'll go into salt marshes and take pores and find out what was going on in terms of plants and all the rest of it. So it gives them a very good idea. It's not just modeled. This is real life indicators that they're using to ground truth.
Thank you.
Yep. The other thing that this slide shows is that you will see some people that try to say, okay, we've been measuring sea level since the 1800s and here's where it is today. And when you do a regression line through that period of time, sea level rise doesn't look too bad. But if you break it up as to what's going on by decade, you can start to see that there's an acceleration component going on. And since the 1990s, don't know if it's I've got another slide in here, but we've seen about, in the last, say, 20 years or so, of doubling of the sea level rise rate here in our area. So this is just talking about Pine Island. This is from the Financial Express. And sea level rise by 50 centimeters is many times more than what's needed to submerge most islands and coastal cities around places like Singapore and those other areas. If we get to several feet of sea level rise, you start to really see problems for virtually every major coastal city in the world. So, one of the other things that's a little difficult to understand is, and it gets into, remember I was talking about relative sea level rise and what's important, is that as these ice sheets start to melt, the distribution of those waters, intuitively you would think it's going to level out, but it's not. The distribution of this water is going to be different around the globe. And when we talk about Antarctic, you can see we're in the north up here, where we're going to be in the winter circle for all the water coming off the Antarctic. So these are some other things to sort of that will play out. So this is a study, and this is out of Science Alert, found that sea level rise is already impacting coastal storms 4 times faster than what we thought. This is the other problem that we're having. We know very little about climate change when it comes down to it. And things are popping up all the time that we're learning and starting to understand. The problem that we're having is we try to model the system to see what we might project into the future. The real world's actually changing faster than we can model it. The other thing then that's kind of scary is that often the real world results are worse than what we're modeling. So we're underestimating what the problem is many times in these models. This is a recent one that I just picked up, but sea level rise is guaranteed to rise by 5 feet by 2100. So there's a group of scientists out there that are saying this is essentially baked in. We got 5 feet no matter what you do, and that's a real problem for many areas, obviously. And so, as I said, from the 1990s, to here, we've seen roughly a doubling of the sea level rise rate that we're currently experiencing. And there's some other things to think about, because that graph that I was showing you where we had CO2, atmospheric temperature, and then sea level rise, there are studies that have sort of taken and looked back into the geologic past and trying to use that as an analog for what we might expect into the future. Although the pace of change that we're seeing is much greater than now. But these are some of just excerpts out of that. And as you can see, there's some significant potential for sea level rise that some scientists are saying that's out there. And again, it's not just carbon dioxide we have to worry about. We have to worry about methane. This is actually on a lake in Siberia. They cut a hole in the ice and lit it on fire, and they're using that as a campfire from the methane that's coming off of that. As we start to see permafrost melt in the Arctic, and the Arctic is one of the fastest changing places on Earth right now, as that permafrost starts to melt, it releases methane. So methane can be a real unknown for us in terms of what the potential is for warming the atmosphere. The other things that are out there, so when we think about tides, which then get sort of factored into what sea level rise looks like and what, because it's sort of driven off of what we call mean sea level. When we think about this, we have the ocean, we have mean sea level, but we have high and low tides that get factored into all this. When you look at tides, they're usually a product of the sun, the moon, and the earth, and how they line up in their orbits. Well, the moon's got a little bit of a wobble right now, and so what they're now saying is that wobble could start to cause us more nuisance flooding. And nuisance flooding is usually considered like this sunny day flooding, or flooding that's usually, say, 1 to 2 feet, and it occurs fairly frequently in some spots. This is the Watchhill Yacht Club, as I was telling you, which we're already starting to see this. The other thing that's kind of interesting, the Army Corps did a study to look at cities around the U.S., particularly the East Coast, and just wanted to see what that first foot of sea level rise would do. And there are places like Norfolk right now that experience about 20 days of sunny day flooding. 1 foot of sea level rise will bring them up to 300 days of sunny day flooding. So that's a problem. And when we were working, did some depictions of what this might look like. This is Newport, so that's 3 feet of sea level rise. And Karate Park, 3 feet. Another thing I have to point out to you, and so you can go and there's any number of places you get tide charts, and you can see the highs and lows and all the rest of it. So when we look and we think of high tide, where it's going to line up on our shoreline, we also, the coastal business, have to account for these anomalies, and there's usually about 8 to 10 extreme high tide events that occur during the year for us right now. That can add on another 1.5 to 2 feet above the normal high tide. So if you're thinking about a building, you want to account for that. So that 3 feet could occur on one of those high tide events with only a foot of sea level rise. So that's something else to keep in mind. The other thing is that there's not just one estimate of what sea level rise is going to be in the United States or within, the federal government itself. There are a number of these that are out there. The Army Corps tends to be lower than NOAA. NOAA is considered the people to go to for looking at water levels and glacial studies. I don't know if the Corps would ever admit this, but in private discussions with them, the reason they tend to lower their sea level rise estimates is they said if they ever used NOAA's sea level rise estimates, they couldn't build anything because they couldn't afford to build it to account for that sea level rise. So, coastal storms and erosion. Why are we talking about that when we're talking about sea level rise? Because they interact. They have a synergistic effect, and it's not a good one. So, let's get into it. Right now, unfortunately, this didn't appear as very weak. But what we're seeing is that we think from the 1980s to now, the storm damage, as you can see, is a very faint line. I apologize for the slide. But storm damages are increasing. And there's a number of factors for that, which we can talk about here in a second. Just to give you an idea of erosion on our shoreline, this is Browning Cottages, down on our south shore here. And this is a series of photographs taken from roughly the same spot. But as you can see, back in 1972, very healthy beach. There was actually a volleyball court out in front of this. By 1992, the erosion was already up by the buildings. By 1999, it had a very deep erosive scarp. And by 2007, it was essentially starting to eat in. And by the way, this is the person's septic system here. There's only one cottage left. The rest of them moved. The other one, the next storm that we have, will probably have to move because there's no more. What you don't see here is there's a pond on the other side of this, so they're getting squeezed in that land. What happens with sea level rise and coastal storms is, in our area at least, because we're a sediment-starved situation here, is our beach wants to roll back. It wants to move backward into the system in response to the storms and sea level rise. And I'll show you here in a second. The problem is we're trying to fix the shoreline in one spot, and it doesn't work. And so, particularly in situations where they're caught between like a pond or a wetland on the backside and the frontal side, they're experiencing erosion. It's a real problem. And we've had some events in the past. And this is the other thing that people and your clients are going to have problems with, because we haven't had a major event here since 1954. The real one was 1938. There's very little institutional memory left anymore about these storms. So people don't understand what they're capable of doing. And so there's this sort of complacency that's out there that, okay, we can build to the shoreline and it's not a problem. But as you can see, Misquamicut was essentially wiped clean in 1938. This is 2012. This is Sandy. So Sandy was a tropical storm, not even a hurricane here. Maybe what we would call a 25-year event. So what you'll find in coastal engineering is they set these return period storms, meaning that this storm has a certain chance of returning every so often. A 25-year storm would, in theory, have the potential returning once every 25 years. A 100-year storm once every 100 years. So this is about a 25-year event down in Misquamicut, and you can see even one small event like that did down there. This is again Misquamicut, showing it back in Sandy. Now here's a fun one to look at. You'll see the stairs are up here. Watch this. That's where the sand was. So this much sand was removed from the system. There's, depending on the storm, the wave action, the direction, all the rest of it, it will either be washed over the system. So if we go back here, you can see these are what are called washover fans. So the sediment is moving from the foreshore across the feature going here. That's because our system wants to move back. It wants to get back to this area here to stabilize this feature. When we don't allow it to do that, and we try to take the sand from here and put it back here, we're actually destabilizing the feature and making it more susceptible to storm damage. But that's what people do because they want to continue to occupy these areas. So again, that's the amount of material that's lost in that particular location. So when we talk about storms and we plot them out, there's two tide gauges that we use. Here are reference tide gauges. One's up in Providence, the other one's Newport. The Newport is the longest one. But this is just showing how some of these line up in terms of the surge itself. And as you can see, we get these two outliers out here that were our big events. This is some of the others that we've had recently. The perfect storm in '91, the '78 blizzard. There's Sandy. And as we start to see sea level rise, that event will move forward. So, and I'll explain this here in a second, why that occurs. Again, this is down in the Browning Cottage area. This is the only one that was left. They actually had to take this house, pick it up, and move it back further. This is the day of Sandy. So, and what happened is these people had a solid concrete foundation, not a pile supported foundation. The sand eroded from underneath the foundation and the house tilted and was condemned, so they had to just move it back anyhow. Okay. Anybody recognize this? South Kingston Town Beach. Many, many years ago, actually it's 1994. I want you to pay attention to the fact that there's a large chunk of beach here. There's this pavilion and boardwalk, and then the actual building itself, Beach Pavilion building. That's the day after Sandy. All that other stuff, go on. That building has actually been picked up and moved back another 100 feet now in order to accommodate what's going on there. So our shoreline's retreating. In many cases, there are areas, and I'll show you some maps here that predict what the erosion is going to be based on historical. And then we've actually done some accelerated erosion based on what we know from the science going forward. Recognize that one? How many of you been to the Oceanist?
Sure.
1991, that's the Oceanist.
Wow.
You would go down there today. So as you can see, we've already lost a lot within the system. In this particular area, we're actually losing system offshore, sand offshore, and we are moving back. I could spend the next hour talking about that, but anyhow. The other thing, because of this, is that sea level rise interacts with erosion, so that when we see how it responds to sea level, it's 50 to 200 times the rate we're seeing in terms of sea level rise itself. So since 1939, we probably had here in Rhode Island about 10 to 11 inches of sea level rise that's occurred, and it's accelerating now. I brought this in because this gets into the discussion of storms and what we talk about. And there's a couple components I want you to think about here. The first is that when we talk about storms and their impacts on structures and real estate erosion and the rest of it, there are two things that are modeled. One is called the surge itself. So the surge is this red line here. This is actually what the storm envelope looks like if there was no wave action on top of it. Then what happens is there's a wave envelope that's modeled on top of the surge, which gives us the base flood elevation. And as you can see, this wave envelope starts to dissipate as it goes across land till it essentially peters out to wherever the surge is going. So when we think about, here, D zones, A zones, coastal A zones, X zones, a B zone is capable of supporting a 3-foot wave on top of the surge. The reason that's important is 3-foot waves take out structures. The other aspect of it is that we now have what are called coastal A's, which you have to essentially build to a D zone standard. Coastal A's are from that 1.5 to 2.9. So again, very damaging waves. This is why they require you to build up on piles and the rest of it. And then we get into the A zone, which is the surge, essentially. It's the flooding zone that we see. The most damaging zone, obviously, is in the waves. The other thing that we talk about, as I started to discuss here, are these return period storms and nuisance storms. And so this is just pulling out of the literature what they actually are. But we, from a coastal engineering perspective, use these all the time. The problem I have often is I go to talk to planners or other people in the local building offices, they have no idea what the hell I'm talking about. I might as well be talking Greek to them, because they're not trained to understand this stuff. But this stuff is incredibly important when you're looking at structures. Yes? Oh, I thought you had you.
Can I ask you a question? Is there a difference between the bay side versus the ocean as far as you're seeing erosion occurring in Rhode
Yes.
Island?
Yes. The ocean is much more erosive than the bay, but again, there's a qualifier there. It really depends on your location. The other thing is, and I'll just point this out, and I was going to get into the discussion of this here in a second. When FEMA looked at modeling the shoreline, FEMA doesn't actually do the work, by the way. There are contractors that do it. FEMA lets out a contract that these guys go do the work, and they're doing it the quickest and dirtiest way they can do it. They really screwed up Bradley here in Rhode Island. So when we look at the open ocean, as I said, waves are the most damaging, so we get concerned about the waves that are coming in on that south shore. As we get up to the bay, it changes a little bit. Yes, we're still concerned about waves in certain areas, depending on the fetch. So fetch means the distance over water which wind has an opportunity to blow over. The larger the fetch, the bigger the waves. So as the wind is allowed to blow over a longer surface of water, it can generate bigger waves. And when you get to the bay, you worry about fetch, because you want to know what those distances are, because there are many areas that are protected in the bay, and we don't have to worry too much. Except for this amplification. So our bay is shaped like a triangle. As the surge is coming in and the bay narrows, the water has nowhere to go except up. So we can get as much as a 40% amplification of what that surge looks like from the mouth of the bay to Providence. So the surge will amplify as it goes up the bay. So that's the other issue that we worry about from a storm perspective, but not necessarily from erosion perspective. Much of the bay you'll see too is armored over the years because it's built on bluffs and a lot of historical erosion, and so these systems are there. This is just pointing out that, so this is down in South Kingstown, I believe, and you have the road system here, you have these houses here. You can see one that's already almost ready to go in. What we run off is what's called the coastal feature. So we want to understand where that line is, where the normal system should be. And then what we do is we ask for and this is just showing the proper line extent, so this is showing that building envelope that you have between here and here. And we ask for at least a 50-foot setback. And as you can see, some of these areas are getting squeezed where they can't meet it anymore. That house, if they had to relocate, is going to be very hard pressed to get the same structure back.
Grover?
Yes.
Is this why a lot of those homes in South Kingstown have to be moved?
Yes.
Okay.
Again, this is just, so what this is really showing is there's a surge in waves, but it's also showing the effect of sea level rise on the existing system. So if we were to start to have sea level rise, what it does is it allows the storm to set up higher than it did historically. So if you have a foot of sea level rise, it just makes sense that whatever was impacted, you have to think of another foot on top of that to see where that envelope's going to go now. In this case, this with 4 feet of sea level rise, this house is going up. Now, FEMA screwed up badly. This is down in Misquamicut. This is the breachway down there. These are what we call base flood elevations, or what they would drive their maps off of. What the prediction here is 18 feet. Then we had Sandy. Sandy was a tropical storm. Went into New Jersey. It wasn't even a hurricane. Thank you. It wasn't even a hurricane going into New Jersey, and it took out close to 360,000 homes or damaged them. It was a surge event. Here, after the storm, this is after Sandy now, you would think that after the experience they just had in New Jersey and New York, they might hedge their bets a little. What they did is they lowered the estimates now by 3 feet. So we had a meeting with them, and we said, you guys are nuts. What are you guys doing this stuff? And they essentially shoot us out of the room and said, unless you got a study, we don't hear from you. So we did the study. And this is, again, one of these things. So you've got 22 feet here along a flat surface, and supposedly the storm is going to go from 22 to 14 on a flat surface. It's physically impossible. These maps are code. So, this is just a plug for, basically, we really have to start being aware of the FEMA Flood Insurance Program, because it just instituted FEMA 2.0, and I understand there's already been a seminar on that. If you guys didn't attend it, you may want to look at it, because some of the flood rates here are going to change. Some are going to go down, some are going to go up. And this was taken out of one of the studies where an analyst said that a policy today could cost $5,000, well, $1,000 today, $5,000 in 10 years, and $27,000 in 2 decades. And this is because of this projection that we're going to see, as well as the rates starting to adjust, because most of the rates, okay, if you don't know this, the flood insurance program was created back in the 1960s. It was actually created to look at the average annual storm, and that's what they based their flood rates on. It was never intended to account for storms like Katrina or some of the other storms we're seeing now. So what happens is that depletes their reserves, obviously, and then they go back to borrow from Congress to get the money. And we're seeing that more and more often. So what Congress is saying, okay, the program's not sustainable, we need to figure out a way to make it more sustainable, so we need to start to jack the rates up. And so 2.0 is intended to start to account for some of that and start to adjust it. But a lot of properties are, the flood insurance rates are under current market value in many areas. So the other problem that we have with FEMA is when FEMA goes to do their flood maps and they look at a return period storm, typically what we see is a series of curves that they predict what the storm's going to look like based on confidence intervals. So this gets into a little bit of statistics, but everybody know what the mean is? The mean's the average. So half the time you're right, half the time you're wrong. Well, FEMA, when they go to do their maps, uses the mean rather than going to the upper 95%, so that they're relatively sure you won't get taken out when that storm event goes. It's a coin toss. You may not get taken out. You get about a 50-50 chance of seeing that. Yep.
Sorry. What is your level of confidence in their new rating system now and how they are kind of behind the scenes geocoding addresses? And I mean, if they're still using what they feel is the base flood elevation, do you feel as though some of the new rates will be accurate now?
No, because the maps are not accurate. They've not gone back and built it. So here in Rhode Island, there's several issues. So when I was showing you when they went to lower the firms here by 3 feet, we had a bunch of research coastal scientists go and look at what the hell was going on. So we did that study that I was talking about. What we found is that the contractor got lazy, and rather than going to offshore to get the wind estimates, we're setting the wave envelope, because remember it's wind that generates waves. They went up to Quonset and took the Quonset wind record. So if anybody knows anything about wind, wind starts to diminish as it encounters land, and so you're going to see a drop in the wind envelope that we're seeing. So FEMA's estimates from their maps were that our wave envelope offshore for a 100-year event, so to give you some reference point again, 1938 is about a 2 to 250 event, 250 to 200 year event. 54 is about a 100-year event. So that might give you some perspective of what I'm talking about in terms of these storms. They said that we could expect 4 meters, about 12 feet of waves offshore. Well, 12 feet of waves for us offshore, that's a bad day. That's not a 100-year event. Should have been 9 meters. That's how badly they screwed up. When they came into the bay, they forgot to account for the amplification of the surge. So then they have another issue inside the bay. So that's just some of the problems with FEMA. The other thing is that FEMA, because they bill themselves as an insurance agency, and they're selling flood insurance, they set actuarial rates. So the actuaries turn around and look at what happened in the past, not what's going to happen in the future. And to me, the analogy that I use is, well, that's like driving down 95 with your windscreen blacked out and you're using your rear view mirror. You're not going to have a very good experience. So FEMA doesn't account for anything in the future. And I should say this, virtually every regulatory program in the United States does not account for any change in the future. They're all locked in today. So they don't think anything's going to change, yet we know it is. We can see it. And that's just, the problem that we have is that our bureaucratic systems, the natural systems are outstripping our capacity to change. And so we get some real issues, and we're really going to have to start thinking out of the box on this one. Well, how does this affect the real estate market? Well, it's kind of a mixed bag. This is how they CompuShare and National Mortgage News. We're seeing a price sale surge. In a lot of areas, and again, I can tell you that most markets do not account for the risk that they're seeing or could see. We're very optimistic in the coastal areas. We're believing we're going to survive these things. And hence, the real estate market really hasn't dipped. In fact, it's gone crazy in some areas. You go to Miami. Now, Miami is like ground zero for climate change and sea level rise. But they've got a building boom that won't wait. Now, some of the smart ones are starting to figure out and going to higher ground, and they're actually displacing some of the poor neighborhoods to take that higher ground, because that's where they used to be. But we really hasn't seen that kick in, and that there was a lot of newspaper articles and other articles about that collapse of the condo building in Miami and what it might do to this if it was found out that it was somehow related to sea level rise. There's some issues there, but if the market starts to factor the risk in, we're going to see a significant change in prices on the coastal areas. And this is, as I said, one of the things is the insurance companies are starting to get shaky. It's not even so much the retail market as it is the reinsurance agencies that really worry about this stuff. The retail market can respond relatively rapidly. You know, they can take a policy this year and you may not have a policy next year. They're gone. You're on your own to find it. But it's the reinsurers that are insuring the retail guys that really worry about what we're seeing, and they're starting to push some of these guys on this. So we have about 4 in 10 Americans that live within coastal areas, and that there's some that are saying that we're starting to see a downturn in prices. And there was an article about a year and a half ago from First Street Foundation, printed in the Providence Journal, about how they're predicting that market prices are already starting to change in a negative way here. We're not seeing it in what I see, but that was their analysis. So like I said, it's a mixed bag. One of the things that is going to get more and more difficult to ignore is as these storms get larger, stronger, and more damaging, both the insurance market and the federal government are not going to be able to continue to afford it. So something's going to kick in. Once it kicks in on the insurance market, we're going to feel it in the retail market in terms of, or real estate market in terms of price. I'll just give you one example. Houston is known to flood at the drop of a hat. And if you look from 2010 to now, they have had 500-year events. No, yeah, 500-year events. 2 of those are closer to 1,000-year events. Harvey dumped 50 inches of rain. And there was another storm that came in behind Harvey a couple of years later, dumped even more rain. What's happening is hurricane behavior is changing these days, particularly down south. And these storms are getting larger and they're slowing as they encounter landmass. What that means is that they're dumping an immense amount of rain on the watershed up above. So some of the people are starting to think, well, whether it's a Cat 5 or Cat 2 may not be as indicative of what the damage we could expect as the forward movement of that storm. Because if that storm slows, we're not going to see as much damage on the coast, but the inland side is going to see a lot more flooding damage associated with it. So that's one of the issues that we're having. The other is that these storms are getting stronger. I mean, the one that would appear in the Bahamas here a couple of years ago stalled in the Bahamas at 185 sustained winds. I mean, that's just, I don't think we have much that would survive that here. So, and so they're becoming increasingly expensive to insure, and starting this month, the new 2.0 kicks in. So we're going to see a mixed bag in terms of that, in terms of rates, because some are going to go down and some are going to go up. And it's interesting because a lot of the homes that I used to deal with when I was at the council were that frontal row. And they're very important to the coastal communities. That frontal row in South Kingstown is 20% of the tax base. When Steve Alford was town manager there, he used to complain to me all the time, you don't understand, we have to keep this front row. I said, Steve, there'll always be a front row, don't worry about it. It may not be where it is today. And that was gravy to those guys because that's second, third, and fourth homes, so there's no draw on services, it's just pure tax. So they're very interested in this. And the other thing I'll just tell you is in Charleston, we used to have these arguments with the planners. We want to elevate the structures higher. Well, we don't like the look of them, we want them down lower. We said, well, it's a case of survivability. Do you want a person to be able to walk in their home the next day? Well, they really didn't care about that too much. And I said to her one time, the planning on there, I said, that's 50% of your tax base you'll lose in the next 100-year event. How do you recover from something like that? They never think in those terms, but that's what we're talking about. And so these are some of the sort of the things I lifted out of news that's relatively recent. So they're shifting from safer areas and they're moving to some of these more risky areas, both in terms of not only climate change and sea level rise and hurricanes, but also things like forest fires and heat and the rest of it, droughts. I can tell you water supply is going to be a big issue in the West. Obviously fires are already a big issue, but yeah. And this one's another one, this is out of Popular Science. There are 50 million Americans of substantial risk of flooding in the next 30 years. And more than 3 million are certain to be underwater at some point during that time. This was down in sort of the Outer Banks. And it's kind of interesting because there, the Carolinas are very, very protective over the real estate markets. And so they're trying to, at last-ditch efforts, do whatever they can to save some of these places. And so one of the things that we're looking at is nourishing beaches, because you want to have a beach, because that's what draws your tourism. And it also acts to protect your homes. So they do this constant re-nourishment down in the Carolinas, and as you go from basically New Jersey south, there's a lot of re-nourishment projects. But they were looking at having to put an increase on property taxes by almost 50% in order to afford this. Now, depending on the storm cycles that you see, that beach could be here today and gone tomorrow. You put it in, and you get another storm next year, take it out again. So it's one of those things that's sort of a crapshoot in terms of how long that's gonna last, but if you're seeing 50% tax increases, and you now have to put that beach back again next year, you can see what's gonna happen in some of these areas in terms of property tax. The other thing that's interesting is the beaches are shrinking by almost 14 feet in some of these areas, so. And I think this is probably the takeaway. There's a whole lot of research right now that's showing that most people don't think about it, they don't care, and the market certainly doesn't seem to be responding to the risk that's there right now. So I guess that's good news and bad news. One thing that's kind of interesting here, the Army Corps is noted for being basically, if there's risk, they don't talk about it too much. But in New Orleans, so New Orleans, they have this $14 billion levee repair. It's the largest civil engineering construction project in the country. And they're saying that the fix may not be adequate. And the Army Corps said, and we need to question how long New Orleans is defensible. So they're already facing the issue, and I can tell you Louisiana's caught in this quandary because Louisiana's, so when you see land sink, that's called subsidence. Louisiana has world-class subsidence rates. So their land mass is sinking rapidly. Sea level rise is coming up on them, and they're already starting to lose towns in Louisiana as a result of this issue. New Orleans is already below sea level. Those levee systems are really designed for Cat 3. They routinely get Cat 5s in there. So it's a question of how much money can you keep pouring into an area that's doomed? And essentially, that's what people are starting to ask people. So what's Rhode Island doing? Well, in Rhode Island, we have the Coastal Council. The Coastal Council was set up as a permitting agency, which is sort of rare for coastal programs in the United States. There's only really two major ones, California and Rhode Island, that have this type of setup. The other interesting thing is that when we were looking at structures, we were concerned about two things. Did it cause an environmental harm? If it made it past that leap, was it going to survive? So we look at survivability as one of those things that we get concerned about. The municipalities tend to say, is it going to look good? Does it fit in with the character? And so there are different frameworks. But we're both sort of looking at these issues on a property by property basis, but we have different frames of reference that we're looking at. What the council did is, when we started to develop our new plan for the shoreline, is there was a new set of sea level rise estimates that came out in 2017. Prior to this estimate, it was about 6.6. Prior to that, about 5 years. Before that, it was about 3 that we were looking at. So as you can see, the estimates are going up and up and up. This came out of this, so the 83% confidence interval. So this is, again, getting back to that, do you want a crapshoot? And you say, half the time you're right, half the time you're wrong. We went to the higher confidence interval because we permit not only homes, but we permit sewage treatment plants, bridges, those types of things. You want to be sure that they're going to survive because the design life of the bridge is 100 years. You don't want to underestimate that one. So we went to, that estimate gives us about 9.6 feet. So we developed a 10-foot level estimate and projected that across the landscape. And those extreme high tide events, as I said, 1.5 to 2 feet. So we developed a 12-foot layer, just to get an idea of what that might look like a couple of times a year. Because again, from a building perspective, you want to account for that. So these buildings are watertight to accept those higher levels. And then the report within it says, and by the way, because we really don't know these uncertainties associated with Greenland and Antarctica, you really ought to think about erring towards the higher side than the lower side, because everything we're seeing is all going up. And by the way, as I said, sea level rise will continue for the next couple hundred years. So by 2200, It's estimated to be 31.8 feet. So, this is some of the technical issues, and I started to get into this already, and I won't bore you anymore with that, but they have a series of technical issues associated with FEMA maps that we wanted to try to deal with and correct. And this will just show you visually what's going on. This is FEMA's estimate of what would occur down in Nitty-Gritty. And as you can see, by these color codes, FEMA's estimating, say, by the backside, we're getting up to about 10 feet. I'm going to tell you, the color ramp on both these maps is the same. When we went to take, and what we did is we took, after sending the Army Corps was given $19 million to go and do one of the largest modeling efforts that had ever been done in the United States. They modeled essentially storm systems all the way from the Caribbean up to the Canadian border. They ran a series of models and they developed what are called synthetic storms to sort of deal with FEMA's problem of looking backwards. They use what are called synthetic storms, which means what they do is they take a storm and they'll change the forward speed, or they'll change the track. And the model of that storm is if it actually occurred. Here in the Northeast, I showed you those two outliers, 54 and 38. So when you go to run and try to do a return period analysis, you got two extremes out here and then a bunch of data down here. By generating synthetic storms, it allows you to smooth that curve out and get a better estimate of what that 100-year map looks like. So that's what we did. Then we took the Army Corps, what the Army Corps did is they did model runs at what they call save points. So they picked a point on the shoreline and they ran those storms as if they occurred. They ran 1,000 hurricane events at those save points. Then they ran 100 extratropicals, or what we call erasers, at those save points. So all that data was sitting there. And then they go to another point on the shoreline and they run it again. And it took them months and months using supercomputers to do that analysis. So they came out with this incredible study called the North Atlantic Comprehensive Study. The problem is that most coastal programs and certainly the communities don't know how to use that stuff. So it's just sitting there. So it's like having a cell phone network going across the world, but you don't have a cell phone. And that's what it was. And so we took their study, and what we did is we knew they were working on it, so we convinced the Corps to run extra save points in Rhode Island. So 18,000 from the Caribbean up to Canada, and we did 1,000 in Rhode Island. So then what we did is we took the Corps' grid, and we didn't like it because it was at a 30-meter resolution, which wasn't good enough for us because we wanted to get down to a very fine level of resolution so we can actually do property by property. We downscaled their grid to 10 meters and in some places 5 meters to start to run these storm events. So that's what that map over there is showing you. I don't want to bore you again, but what FEMA does is they run what's called a transect model. So they run a transect on this area here, and they figure out what the waves and the surge are doing. Then they go a mile down the shoreline, they run another transect and figure out what's going on there. And then what happens is some kid in a back room is trying to figure out how to join those two lines together along the shoreline. So he's got a point here that says V zone, point here that says V zone. He's trying to follow and figure out how that connects. These models pick up all the wave interactions, currents, and the rest of it. So that they account for all that without having to try to guesstimate what that looks like. So that's why this looks like. And you can see the resolution is much greater here than it is here. So we estimate that they're going at 10. We estimate by the time you get to the backside, it's 20. Big problem. Because if you're building to the 10, you're gone. And the other problem, as I said, FEMA doesn't account for sea level rise, so that's an issue going forward. So what we did is we developed here in Rhode Island this thing called Storm Tools. And what Storm Tools does is it models all that stuff and then projects these layers. And what you're seeing here is the sea level rise map. And what we did is we went, and it goes up to 12 feet now. This is an older slide showing that it went up to 5. But what it does is it shows you what would be flooded. This is the current base 100-year level storm. And then if you add a foot of sea level rise, that's where it would go. And if you add 2, that's where it would go. And if you add 3, so what it does is it shows the extra flooding that would occur with sea level rise. So while you may not be flooded today, you might be in 10 years and 20 years. Now the reason we went with these intervals like this rather than time slots is because sea level rise estimates changed 3 times while we're working on this plan. And so this allows you to match the sea level with whatever the current estimate is. So you don't have to redo the maps all the time. So you can take and you can use these maps and you can go on this thing called Storm Tools for Beginners and you can punch in your address and ask, okay, am I going to get flooded with a 100-year event? And you can start to see this. And this is Wickford, by the way, that you're looking at here. So this is just showing what a 19, and they said 38, 38 is actually a 200-year event. It's 54. Oops. This is the slide I got from the university. Anyhow. You can also look at sea level rise. So this is just pure sea level rise. Will my property be impacted by sea level rise? And again, you can match those up with the rates. I mean, the sea level rise rates. And then what we had done is because we had this in a geographic information system, being a computerized mapping system, we started pulling in other databases, and it gave us incredible capability. Rhode Island, and this system was developed probably about 5 years ago, 7 years ago. There's nobody in the United States, including the federal government, that has even come close to doing what we've done here in terms of capability of the system. This is showing now what this did is pulled in the E911 database, and this is density mapping associated with residential development and flood events. So it starts to give EMA directors, okay, if you have to respond and get evacuations, these are the most dense areas where you want to get in there and start getting people out. Again, this is a critical facilities layer. So this looks at schools, it looks at fire stations, police stations, all that. And it starts to show what issues are. And as you can see, this is Warwick and this is Warwick Neck. They've got a fire station here that's going to be underwater, just a normal storm event, meaning a 100-year event. And then sea level rise makes it worse. These are schools. So again, when the city wants to then look at building a school or a new firehouse or whatever, this gives them the ability to look and find a site that's going to be out of the problem so they're not taken in. The other thing that this revealed to people in Warwick is Warwick Neck will not be accessible in a 100-year event. There will be a debris line up there that will block access to Warwick Neck throughout the storm and probably for a day or so after the storm. The problem is the power lines are coming down and all the rest of it during the storm, it can start house fires. And if you get a house fire up there, you're not going to get to it. So what you may want to think about is pre-positioning equipment on the neck for those types of events. So this is the type of stuff that this gave us. And it goes well beyond this. The stuff that we did was bordering on science fiction in some of the areas that we were looking at. This is erosion maps. So this is on the council's website. What this does is these are 50-meter transects. What they do is they depict previous shorelines here. So you can start to see how the system's moving back. So this red line, I don't have it on the key, but that's the 1939 shoreline after the 38 event. And as you can see, the shoreline's moving back, but it tells you what the total loss of volume is in that transect, and then what the annualized rate is. Now, obviously, erosion doesn't occur a foot every year. It may be stable for 10 years, and then they'll lose 15 feet. And so what we do is we calculate the average over that period when we're looking at setting structures back, trying to estimate where a safe place is for these people to build. So these can be found on the council's website. They appear as PDF maps, and you can zoom right in on the area that you want. Or there's another tool that I'll show you here in a second that you can use. So what we also then did is look at erosion, and we said to our coastal scientists that were working with us, these geologists, we know intuitively that, that erosion is going to accelerate as sea level rise starts to accelerate. Can you give us any idea what it looks like? So they started to look back at all the research that had been done on historical shoreline movement. They also looked at physical models, trying to deal with it. And so what they came up with was these estimates. And granted, they're rough, but we wanted to have some idea of what we're doing. So what this does is it accounts for the geologic setting in here, because you can see this band is much narrower than this one, and that accounts for the geology, the underlying geology that's here. The red is essentially gone, and this is by 2100, and this is the high scenario for us. We have a high and a low scenario that we ran. This is what would be the estimate of where the feature is. Then we have a residential setback and a commercial setback. So as you can see, it goes well into the neighborhood here, and that's down in the Tulic area in terms of erosion. And again, we did these maps for planning purposes to try to understand what we might be looking at in the event that nothing is put in place to stop this stuff. And where we should think about, particularly for infrastructure, where we should start looking at where are acceptable places to put infrastructure. So, this is looking at sea level rise scenarios, just sea level rise scenarios, not storms. And it looks at, oh, I'm sorry, it does take into the 100-year event here. So, and it ranks them. So, for 3 feet, South Kingstown's #1 for risk. Tiverton is #5. You change the sea level rise, and westerly southerly picks up. This is due to topography within each community. So, by the time you hit 5 feet, westerly's got a lot more low-lying areas than South Kingstown does. So,
Wait,
and then you go on.
worst? Did you say 5 is the worst? Based on that?
5 feet, well, 7 feet's the worst here.
Right, okay, the rank.
The rank, yeah. It,
Is 1 the worst
No, 1's the
or
worst.
5 the worst?
one's the worst.
One's the
One's
worst.
the worst.
Right.
I'll tell you though, the town of Warren, they got a lot of problems. Because they got a lot of low-lying areas, and not a lot of options. This doesn't really reflect some of the patterns of development and the rest of it. And so there are communities that, as you get into the Bay, are much more risky than some of the South Shore. The 100-year event, Warwick, is the problem. So one of the things we did is we developed this brochure, and it really is in need of updating, but it was actually developed with the Realtors Association.
Very good.
Conjunctly. So this looks at things you ought to think about, things you ought to take into account. If you're looking at buying, building, or rehabbing, these are some of the things. And there's an online version of this, and I don't know, I can't vouch for the link. It used to have hot links in it that would take you directly to the data sources itself for this type of stuff. Everybody got that? Okay, one of the things we did, because this geographic information system allows us to play with this, is we did what's called a coastal risk index. So the coastal risk index actually started to look at geology, it started to look at surge, it started to look at waves, it started to look at erosion. And looking at them in a combined way, so that we can start to look at the shoreline segments and which areas at most risk. We started to do that, but one of the easiest ways we found to look at this, so that we got a better estimate of risk, was to look at the structures themselves. So, the building blocks of this risk index are the water levels themselves, the wave estimates, the shoreline change, meaning the erosion or accretion, and then damage functions. So what the KWAOR does, and in particular in FEMA after a coastal event, is they go in and they look at the actual damage, like in New Jersey and New York, what was done by the storm. They look at the building type, and then they look at the damage, and they start to build these databases that they can draw regression lines through. to start to figure out what type of structure, at what elevation of water, can you estimate what type of damage would be done. So, we did this as a sort of an experiment with the university, and we took all the building types that correspond to the KWAOR's damage index. And then we took the feet above grade, because this is an estimate of where the first floor elevation is, because that's very important for flooding and for wave attack. And then what we did is we brought all that information in and then put it in a format that people could see and understand. So this is again the Matunic area. Oceanus is over here. And so these colors now represent percent damage to the structure by, and this is just a 100-year event, no sea level rise, of what we could expect in terms of damage in these areas. And this is an underestimate because, one, if this structure gets taken out, all the debris from the structure now loads up on this structure and causes a loading problem, which that structure was designed for and could be taken out. So it's an underestimate from that perspective, but it also is an underestimate from wind. No wind is factored in here. And wind is the most damaging impact from any storm that we see. The entire state is in a hurricane wind envelope for us. So that's what we optimistically could see. And then we put sea level rise on it. So this is 7 feet of sea level rise, not even our worst estimate. But you can see, now I'll just show you, why should be flood envelope as it penetrates into the neighborhood too. So, a lot more red. Red is 100% gone. This one is a little bit different. And so we were going through this evolution as we were starting to deal with this. This one is, again, structure by structure. But what it also then accounts for the homes that are lost from sea level rise and from erosion. So you see these two down here. Blue is lost to sea level rise. This is erosion. So this is today, 100-year event. No losses really from erosion or sea level rise. This now is 2 feet, still not that bad. That's 7 feet. And so you can see there are clusters that are lost to sea level rise. There's some erosion losses over here. So it was a combined indices that started to show us a little bit more than what we were looking at. Another step in the evolution of this tool was this. So this is up in Barrington. This is, again, so what this is now showing you is the percent damage to the building, but it's also showing what the flood level is and the depth of that flood level, because whether it's a foot or 5 feet is a big difference in terms of how you respond and the damage you might expect. So this is sort of taking into account those factors. So you've got on one side of the bar graph there, the depth of water, and the other is the actual building you can see. So this is just a 100-year event today with no sea level rise. And that's with 2, that's 5. They didn't want us to go beyond 5 because their towns have trouble trying to get their head around anything beyond, say, a 5-foot sea level rise, which is mid-century for us, 2050. So this is just showing what they could expect. Now, the interesting thing is that their old tourister factory there was developed. In that first floor of condos, when we permitted it, it was a historic structure, so it's one of those things you don't necessarily tear down and take out of there. But we told them their parking lot's gonna be underwater. And they're selling those with their parking lots that are potentially gonna be underwater. So, I don't know what type of disclosure going on, but this one is down the westerly area. This one's kind of interesting because it did take into account wind. We started to play with wind at the end. And so you not only see the damages per structure, but you're seeing some damage up in the upper watershed, and that's done from wind. So we had to get a little bit more fancy with wind because there are a number of other factors that you have to take into account, such as the nailing type schedule of the shingles and all the rest of it. Fortunately, when you're working with the university, you can 6 students on this, and there are no costs. So, you can put one of these really dreary details where they gather the information so we can start to run that. So that's 100-year events today, and that's how many feet? Doesn't say, but 7 feet of seal rise. So what you're seeing here is this is the permanent, these foundations that are sort of just showing up in black. With 7 feet of seal rise underwater, that's permanent inundation. And then you're getting much more right up in the watershed, and of course the wind damage is going up well into the land mass itself. So one of the things we pushed was this fortified system. Fortified is actually a product of the Home Insurance and Business Safety Institute. It's a institute that's devoted essentially to the insurance companies and trying to help them figure things out. They are very concerned about wind damage, flooding they lead to the federal government. But their products and their construction techniques help people survive these events. So what we did when I was there is we said if you went to the silver or gold system for fortified, we would expedite your permit in the system as an incentive to get it through for this. So Shoreline change stamp is the plan we developed. Essentially what it is a guidance document. It's not a regulatory document. Regulations have changed within the Red Book itself, but this is really a guidance document. It's built off the 2017 83% confidence interval in terms of the seal rise estimate. And what we did is we superimposed at the time, because again, it was, the time this plan was developed was 6.6 feet. So we took 7-foot seal rise, 100-year storm event. Those blue areas are the impacted areas, so that's what the plan was developed for. As we now know, it's 10 feet, 12 feet. So it's a little bit of a different problem. Now the maps have changed to reflect that, but the plan itself was originally developed for that. These are the chapters in it, so it goes into what is a coastal hazard, how we assess the risk, what's Rhode Island's exposure to that risk, and then we developed new application guidance. So the new process itself, so there are certain structures or certain types of development that will trigger this analysis. Not everything does. But if you're building a new home or you're doing a substantial rehab on the home, you will trigger this new analysis. First it says, what's your design like? So how long do you want that structure to last? You want it, and you can run off zero, meaning, I don't care if it goes tomorrow. Or you can build in whatever design life you want. But when you choose that number, it then sets a scenario that you're supposed to look at and evaluate for sea level rise, storms, and erosion. So the next step is step 2, where so this is step 1. This is the design life, and as you can see, there are projected sea level rises associated with the design life as you start to look at this. And then you're supposed to take into some other factors. What do storms do? What will erosion do? And this is an acceleration component for erosion. So what it does is it takes the normal erosion factor and gives you a multiplier that you have to do in order to understand what erosion might do. The purpose of all that is, and large projects or subdivisions or major industrial complexes, they have to take into account the SLAM maps, which is sea level rise affecting marsh migration. One of the cheapest ways that we can preserve salt marshes in the state is to allow buildings to move out of the way so marshes can migrate across the landscape. So in a major subdivision or whatever, they can look at the building alignments and the rest of it and play with those to keep them out of those areas. All that goes into the design elevation, the design evaluation. So we're providing you with all the information for you to look at your house and make a smart decision. You don't have to. You can say, I don't care. Go ahead. In some cases, it still gets factored into this council's staff evaluation because they'll point some of this stuff out. but it's not a thumbs up or thumbs down on your application per se. Okay? However, as it gets into the permitting process, the staff will note that, and I'm gonna show you an example of the staff report that gets embedded into the permit. You say, okay, permit gets registered on title. So it carries with the land. The reason for all that is, I'm a risk taker. What the hell? I don't give a damn. I'm going for zero. And I'm gonna build with no assumptions whatsoever. I decide I'm gonna flip my house in a couple of years. You're coming in behind me, and you have no idea what I just did. The permit conditions will tell you what I just did, not the conditions themselves, but the information in the permit. And I'll show you here in a second. This is just showing the maps, and these are the suggested design elevations. So what this is the flooding. And you can do a 100-year event, and you can do with all these various seal rise scenarios going out. So you click on the tab, and it will show you what that is. You punch in your address, it will take you right to that location. And if you want to, you can go to the council's website. There's a tab on the top of it that talks about damage assessment analysis. Click on that tab, it will take you right into this. You can punch in an address, and it will take you right through all the information you need to analyze that. Whether it's there, whether you're buying a house, you're not buying a house, or you're building or whatever, anybody can access that information and look at it. So it's a way of you understanding what the risk is, so you might convey it to your clients, or at least make them aware that this product's out there so that they can make that judgment call. This is the ones for the Upper Bay, and as I said, it's the open shoreline. I'll just give you one example of down in Wesley. I think the BFE is around 19, so they're estimating that there's going to be a surge with about, I don't know, depends on the estimate, but there'll be at least a 3-foot wave on top of that. So 19 feet, surge in waves. You go to that area on our maps, and the surge in waves are about 35. They dissipate rapidly as it's going across the landscape, but much higher wave envelope. In the Upper Bay, it changes. Waves are not a big deal anymore. Surge is still an issue. Waves are not a big deal, but the amplification is. And so there are two sets of maps. One is the bay side, and the other is the open ocean, and they're dealing with that problem that was inherent in the two maps. There's also, and at the time I left, I haven't checked on this, there's also, you can download an app on your phone, punch in your address, and see what the risk is right there, based on that. And then the app also would allow you to play with assumptions. So you say, okay, current house is at 10, but if they want to elevate it 5 feet, what will the risk change? And it will recalculate the risk based on the new elevation. So it's very powerful. I can't say what happened to the app after I left, but it was an extremely valuable tool at the time. This is the permit conditions that I was talking about. So this is from an actual permit. It says, we recommended a 30-year design life. And this project had a stated elevation of 17.23 DFE, or first floor elevation, I should say, sorry, first floor elevation. It did meet the seal rise for 30 years. It did not, or it does meet the actual acceleration for the erosion, but it does not meet the storm pool design elevation recommended for this, for a 3-foot sea level rise, because that's the 30-year estimate. And they submitted for a 50-year design life, and it certainly didn't meet the 50 years. So that gets embedded into the permit, and that gets registered on title, so that subsequent buyers can make that choice. Do you want to buy it or don't you? It's up to you. So that's the presentation.
Thank you.
So what's being done to, try to get common understanding among town planners and people who should be looking at this stuff?
We actually work with builders association, when I was there, to, one, allow for greater elevation to be used, to account for single rise. So if you take what the FEMA maps were showing to you and add elevation to that structure, and not trigger, because what the municipalities like to do is obviously they put in the zoning height, but you're elevating the structure, so now you end up with this flat structure, and of course, people don't like those. So what this did is allow you to incorporate that height in and not trigger the zoning variance, for that height. And then we worked further, just before I left, to incorporate these maps in. So you can choose between these maps or the factor that the builders have put in, which I think is either 4 or 5 feet, I have to go back and look, extra, what they call freeboard. So what they do is they estimate what the wave envelope and the flood elevation is going to be, and anything above that is what's called freeboard. In Rhode Island, we have a minimum of 1 foot of freeboard that you have to incorporate according to the building code. This allows you to put in extra freeboard without having to trigger the height variances. So that's one of the steps that was done, was basically trying to essentially override concerns, I guess, in certain terms of some of the height issues. Trying to build more resilient buildings. As I said, we were concerned about survivability. We're concerned about tax base in this state, and we were concerned about dislocation. If you look at major events across the United States where they've had significant storms like New Orleans, many of those places never recovered back to the previous population, because when your home's destroyed and you got no place to go and you're trying to find a contractor, God help you at that point, because you're not the only one. People often walk. They just hand the keys to the bank and walk. And they're not staying in the state. They're gone. Rhode Island's having a problem with population. We don't need to accelerate that issue by building substandard structures. We need to have resilient building. We need to have buildings that are gonna be here for people, so.
So do you find those communities, the communities in Rhode Island, using a lot of this data that's
Some
been
do, some
developed?
don't. Some of the more advanced ones do. Some of the other ones try to go as much as they can.
The ones around the coastline?
No, the ones around the coastline, and that was the other thing I didn't point out, is that we've also worked on the Patuxent, we developed some maps for the Patuxent system, the river system. Because as soon as you get out of our zone, nobody cares about flooding. There are supposed to be agencies that do, but they don't really do anything proactively. So we were working on the Patuxent to show, because we were concerned, as surge comes up the Patuxent, it's going to jack up the elevation of flooding in the Patuxent, and we're trying to figure out how those two interact. So what we did is, we put a 100-year event on the Patuxent in a rain event, generated the surge, and then modeled what might happen. But in many of the river systems, coastal areas, many of the communities, Warren, for instance, gets it, and they've been working diligently on this stuff. Charleston's been trying to ignore it as much as they can.
I was wondering, what does this mean for aquifers in Washington County and whatnot? How does this affect it? Are we united?
It's a very good question. There's only so much time I had and what I could get into, but what we're finding here in coastal New England is, so we've got a lot of glacial topography, a lot of unconsolidated sediments, meaning that at the very course. As sea level rises, it also carries the freshwater table with it. The problem is, as sea level moves in, because it's going to laterally extend in, it will start to contaminate certain aquifers. And so people will lose their potable water supply as part of this. The other thing is that you think of septic systems, they're looking at the groundwater separation from where the leach field is to where the groundwater table is. But if that groundwater table is moving up, it's going to take away the safety factor that's built into the septic system. And you're gonna have contamination of the water supply from the leach field. As that water level rises too, you're gonna start to see wetlands where you never saw them before, because they're gonna start popping up across the landscape. There was a study done in New Hampshire with 6 feet of sea level rise. You're gonna see wetlands in Pease Air Force Base that never appeared there before. This is groundwater push. So there's a lot of issues associated with groundwater with that. When we look at Superfund sites, as I said, everything's built as if nothing changes. All the federal and state regulators have blinders on, and they're just saying, oh, this is what it is today. But as that sea level rises, changes, it's gonna start to intercept some of these Superfund sites, and now they're gonna become active again, because they're gonna be subject to Title 40. There's a whole bunch of things people haven't looked at yet. As I said, the ability of bureaucratic systems to change is often very slow versus what we see in the natural environment.
One last question. So now that you've depressed us all.
Put all you on suicide.
So what can you do as an individual, as a realtor even, to affect any change? Or, how should we proceed?
So, as I said, one of the things you may want to do is direct your clients to those maps. There are, and one of the things I didn't get into, there's a whole chapter on adaptation. And the reason we didn't get into it too deep is the adaptation field is changing daily. So in other words, people are coming up with these new ideas on how to adapt our environment, the built environment, to withstand these forces or environmental situations we're seeing. For example, if you look in Europe, I've seen situations where there's a house looking very stately with an old stone wall going around it. That stone wall is actually a flood wall. And the front gate that they have is a floodgate. Looks like an ordinary sort of solid gate, but it's a floodgate. As the flood comes in, that structure is completely protected from any flooding, from that simple little adaptation by building that into the system. So that's just one example of how the people can do it. If they're looking to build a new home, can they build it on a higher portion in the site? And the other thing they really want to start to think about is, yes, your home's accessible today, but you may want to look at the road systems around that and look at whether the sea level rise is going to impact your ability to access those sites. So there are things that people can take into consideration, and I often heard it so many times when I was dealing with permitting situations on the front lines down there. So many people came to us, I don't care if I get 10 years out of this. I'm happy with 10 years. That is until the 10 years is up, and then it becomes important to them again, but that's why we went with the design line. Think how long you want this structure, but also realize that you've got to sell that structure at some point. And people may have the information. If you've triggered one of these analyses, they may have the information to make a better assessment of what you assumed when you bought the house. So there's adaptation, and there's information, there's ways of looking at that. Obviously, if they've got a house that is in a flood envelope and they didn't design for it, elevating that structure can be one of the ways of dealing with that issue very simply. One thing I'll caution you on is you can't put fill on the site to support a structure in a flood zone. But we were allowing people basically to fill their lots around the structure to sort of keep sea level rise out of their yards, so they didn't become salt marshes up to their back deck. So there are things, we're gonna have to change the way we think, we really are. And if the insurance markets or the banks start to really trigger some of this stuff, it's gonna come at us a lot faster than what we.
That's where I think it's gonna come. As mortgage bankers take a look at, you know, what the safety net is for them,
Yeah.
they're gonna start clamping down faster than the rest of the population.
But here's the funny thing, with an article, and it was done by one of the major business schools. And they were saying that what's, and I didn't put this slide in, but what's happening is guys like Washington Trust, they're local, they have a much better idea of what the risk is in these areas. And so they will keep the less risky investments in mortgages and then spend the rest off to Fannie Mae and Fannie Mac. And the problem that we're having is we're setting ourselves up for another downturn in the market, because once those start to come due, we'll see a rise. There's gonna be a crash in the market, and it's gonna be permanent, because there's no recuperating when you get high tide in the front yard every day. And they're seeing that down in Mid-Atlantic. There are homes that can't sell because they got high tide in the front yard every day.
In that, your whole presentation, what's your thoughts on communities building barriers? And does that just displace the problem?
Yes and no. Properly designed, no. The question is, as I showed you, some of these sea level rise estimates are way up there. The cost to build some of this stuff really starts to soar. But we had been looking at, and so when I was there, I got the Army Corps involved in the project looking at an assessment of the bay. And can we start to look at, are there structures that we can put in certain places that we can prevent flooding into the future? One of the ones I was very concerned about at the time was 114 of the Barrington Bristol. That road is very susceptible to both sea level rise and storms. And it's a major route in and out of those towns. But if you come back towards the ocean, there are choke points that you might be able to build structures that would buy you time. How much really depends on this with sea level rise, but you could build structures that would buy you time. And by putting things like tide gates in it, you wouldn't really change the amplitude too much of today's tides. It would preserve the salt marshes and stuff, but you might affect the navigability of some of those. But again, it's something we need to start thinking about. It's out there, yes.
What about like Papa Squash Point over there? I mean,
So there's a lot of areas in Rhode Island. Papa Squash is one of those that sort of, they're not as much of a risk from storms or sea level rise. Quitting Island, for instance, in general, picks up topography very quickly. And not a lot of risk there, except in some of the low-lying areas, and we all know where they are. You know, it's Newport waterfront, it's Common Fence Point,
Yeah.
there's areas like that. Yeah, they're the risky areas, but most of the island doesn't have it. So, Papa Squash is one of those, that, again, that picks up some elevation.
it does, huh?
So,
Not to get out there though.
no.
Accessibility.
Well, you know, one of the things we were looking at was, some places were starting to think about building causeways. So an elevated causeway that would allow the flooding to continue underneath, but pick the road bed up so that you could still access areas. And we were working with a couple of towns to look at those at the time. So causeways may be one of the ways that you continue to maintain those neighborhoods. The thing is that, and again, we're looking at this in many other towns or states' uses, is what they call special tax assessments or districts. So if you've got 5 people that live out on a point, and they want to continue to live there, but the road's gonna be underwater, and it's gonna cost the town $10 million to deal with that road. And you say to them, look, you want to continue to live there, then fine, we're putting a special tax assessment on you to pay for the road. Then you guys can continue to live there, we'll put the road in. Again, something that really hasn't caught on in here in Rhode Island, but it may have to. The other interesting thing is that when we were looking at some of these projects, there's a statute in Rhode Island that says, essentially, if the town is in South Kingston, Westerly, and some of these other areas have roads that are like this, they're flooded very frequently, and they would like to walk on those roads, particularly the ones that are susceptible to storm damage, because they're taken out every time. They just say, okay, we're out of here. Problem is, the statute says, okay, then you buy everybody out on that road for fair market towns can't afford that.
Yeah.
So they're gonna find any printing that they can to try to maintain something. So, yes,
So this is gonna be kind of my next question. What happens when your property is assumed by the ocean? At what point is it considered obsolete, and what happens to the land?
anything below the mean high water mark is considered state property. And this is another issue that we were concerned about. You get a storm, like in the Squamish area. The feature retreats 100 feet back to 38 and then, or 54 and then. Now you got all these structures, and this has happened down south. They sit out in the water. And I'm property owner A, and my house is no longer habitable, and the rest, I go and turn my keys over to him, say, I'm out of here. The bank's sitting on it now, but still value to them. The state's trying to chase somebody down to get the damn structure out of the water now. And down south after Katrina, there are literally ghost towns out in the water that they weren't able to deal with. They're sitting out there just rotting. But anything below the mean high water mark is considered state property in the United States. We've seen systems though, like I showed you where the septic system goes. So what we will try to accommodate as much as we can is holding tanks. So you don't have a leach field on all this, but you get a holding tank that'll hold. Again, buying time.
Robert, you see a lot more, especially with Narragansett Bay right now, where they're buying up and putting pumping stations in certain areas. Is that being utilized to divert water to certain areas, away from certain areas?
To what?
Pumping stations. So Narragansett Bay has brought up a bunch of different, or putting in a bunch, like specifically more in the northern part of the state, but they're doing some southern. I think there's one going down the street.
For sewage?
Yeah. I think for the sewage overflow and the water overflow, in order for that, when we don't have the flooding next time it happens.
Oh, I know what you're talking about. You're talking about the combined sewer overflows.
Yes.
Another interesting thing. Remember I told you no regulatory agency believes that climate's changing? So they built these huge tanks underground. But the catch basins which feed those are at elevation, whatever. As sea level rises, it's gonna catch up with those catch basins and suddenly start to inundate those on a daily basis with salt water, which really messes with the sewage treatment plant. So they will either start to have to elevate those, and if they do, they gotta elevate the road bed with it and all the rest of it. But nobody's really thinking about that. And I was just before I left, I was sitting with the guys at Solid Waste. So if you're not aware of them, we've got a big solid waste problem in the state. Our landfill's probably got about 9 years left. They've got to figure out something to deal with the issue. Not quite sure where they're going. And they said, so we have 9 years left. I said, do you think so? I said, if we get a 1954 event, where do you think all that Demise is going to go? And I said, I'm willing to bet it will take 2 to 3 years off your landfill life. Never thought about it before. Never even considered it.
So should we all move to the Midwest?
Climate change. New England's in one of the best spots that you can be in terms of the United States. We're gonna get warmer and wetter, and that's not too bad. But if you're on the coast, you gotta be careful where you're on the coast. I mean, guys on the cliff walk and whatnot, they're pretty good.
Yeah,
You just gotta be careful.
that's
all.
the bottom line, I
Yeah.
think, what you just said,
Yeah.
yeah.
I just came back from Charleston,
Yeah.
South Carolina. The day that we were supposed to be doing our tour, we were supposed to do a walking tour, but it's pouring. Wasn't even a big giant storm or anything. We took a bus tour and we went down along, some of the waterfront areas, and he said, you see those sawhorses all up and down the street? He said, in an hour, this place will not be accessible at all. It was just comic, it was happening between the sea level rise and it was just happening, and so we're waiting with it. The last day I left, they had a special report, that said low-lying Charleston has limited land to work with as it tries to manage development in the face of climate change, growth, and affordable housing.
Yeah.
So trying to find land to put not just low-income housing, workforce housing, was disappearing, and they realize it's just going to continue, and so they
Oh, yeah.
have this big crisis thing moving now, so, I mean, it was like all of a sudden I was limiting what I've been hearing as a potential for here.
And, as I said, Mid-Atlantic has got some spots that are Norfolk, Virginia. Probably one of the largest naval facilities in the world is down there. And Navy will probably get the money to deal with that issue. The problem is that the Navy, or the fact of the people in the community adjacent to it, that really doesn't have the money to deal with it. So there's, you're gonna see this dislocation of the workforce unless they approach it in some sort of holistic fashion. So again, it gets back to, you need to think beyond just your little block here. You need to, you know, there's interesting, I forget the name, we were approached by this guy out of Florida. This guy in Florida essentially took public information like we have here and manipulated it. And he made a business out of it. So what he does is he'll come in and run a report for you showing, you know, when you can expect your home to be flooded, what you should go to if you wanted to stay above storm surge. And he did, depending on how much you wanted to pay, up to a 300-page report. He even did a market analysis for you as to when you should sell your home before you lose the value in it because of sea level rise. And he tried to get us to buy into it and, you know, get his license fee and all the rest of it. We said, no, we just gave it to the public for free. But he had a guy in one of the areas, I forget where it was. Anyway, I took the information that this guy had. And the guy built his multi-million-dollar home to this standard. It's elevated, built to a very high standard of construction. And then he called all the city officials in from that town and said, you guys need to make everybody else do this, otherwise I'm gonna be an island out here. And he wanted them to push everybody to build to the same standard and elevate the roads and all the rest of it. They just sort of laughed at him and walked off, but, yeah. And I guess the bottom line is, don't buy property in South Florida for a long-term investment.
They did note, in here, and I think, AARP actually had an article about, you know, impact on your life, you know, what's going on, with climate change. And they did cite some of the places in South Carolina, North Carolina, where sales in, property have already started to drop off. Coastal property.
You tend to see it, particularly after coastal storm. You'll see it for a couple of years. Then if they don't get a storm, they start to catch up a little bit again, but yeah. But the flood insurance is gonna kill those guys down there. It's, I mean, you hear policies in Florida that are outrageous. And the other interesting thing in Florida with climate change related is Florida's built on what's called karst topography, meaning it's limestone. And when limestone comes in contact with water, particularly seawater, it starts to dissolve. Which is why you're seeing sinkholes in Florida. So there are certain areas in Florida now that you have to carry a sinkhole policy, as well as some of the other insurance that you have.
My understanding of the flood insurance, it only covers your furnace, your boiler, whatever, and it doesn't really cover much for what you pay.
Right.
It's not a good deal at all.
If you're looking at a $1 million home, no, because you're gonna get $250,000, that's it.
Yeah, it's not really.
But again, a lot of the people that we were dealing with, they went around and they were paying cash for some of this stuff.
Yeah.
Or, you know, private insuring. They didn't bother to go through where they were required to get federal flood insurance on the market to limit them in terms of what they could collect.
Yeah.
So, and by going private insurance, they could avoid requirements on the mortgage too.
Yeah, it's expensive for what you get though. It doesn't cover much.
Well, they're supposed to do lost everything, something that's helpful.
Actually, if you pay attention, so Mary Caruso's presentation 2 months ago about FEMA breaks it down a little more. She said you get $250,000 cover. It doesn't just cover limited, it covers repairs up to $250 based upon the policy. The maximum current policy is $250,000 being budget. But like you said, if you have $1 million house, yes, you're not covered and it's destroyed.
Then no, my misunderstanding.
Yeah.
And I didn't know, I should take the class again then.
The other takeaway I would just say to you is, even if you don't think you're gonna get flooded, buy flood insurance.
Yeah,
Because it's a cheap way of ensuring you if you ever get flooded.
A friend of mine's daughter just she lives in a $1 million house in Westchester, and they just had historic flooding in their town, and her whole basement was finished, and you know her boiler, her washing machine, dryer, they made furniture down there, and I guess the town it's Larchmont. I think the sewage system maybe backed up too, so they lost everything. Neighbors did too. And of course, there's no coverage because they don't have flood insurance. They're not near a body of water. They wouldn't think to have flood insurance. They
I'll tell you,
nothing's covered.
where's one that, so I was talking about Houston floods, so the Army Corps was brought in to say, to look at the situation, see if they could find out a solution to it. The Army Corps said, well, if we build this big flood detention basin upstream, we can stop some of the water from coming in, slow down the flooding event, and meter it out so it doesn't impact town of Houston or city of Houston that much. So they did that, built this large detention basin, but in Texas fashion, somebody was sitting around the room one day and said, geez, that's an awful lot of land with no houses on it. They built houses. Because it was a flood basin and not a flood plain, they weren't required to tell anybody that it was going to be flooded. Harvey came along and the Army Corps sweeps through the neighborhood and says, everybody out, you're going to get flooded, we're going to turn the gates on. They said, what do you mean? I said, you're in a flood basin. And they flooded it. A third of those had to file for bankruptcy down the gate. Another third had to go on short sale. And about another third had enough resources to rebuild, but then got clobbered again by a storm 2 years later. And a lot of them just walked it back.
Jeez.
Thank you very much. Obviously, a very in-depth conversation. I feel like we might be able to have additional classes in the future. For anybody who did need to get anything, as I was saying, all these classes are now put online. We put them online directly after the event. So it'll be there for resource, so you can review Mayor Caruso's FEMA one, which corresponds to this directly, and I'll be able to help you understand that too as well. They're all going to be there. I did see that some people said they had some issue creating online, so if possible, we get a copy.
Yeah,
We'll
we'll drop it up on your, drag it on your.
We'll post that there too, so that the online people can actually go through the screens. Thank you very much.
And I did post some of the links.
Thank you so much.
Thank you.